Well, I'll get started. This is Dennis Ojima. I'm here at the North Central Climate Science Center. I'm filling in for Jill Lackett, who's on the line, but she's not in the office today. We have an opportunity. Sorry. We have an opportunity to hear sort of an update of an activity that has been pulled together, guided by Gabriel Sine from USGS. Really, the hard work is being conducted by Darren Schulte, who's a postdoc with us for the last year, and looking at ways of pulling information together from a variety of applications and to use it as an exploration tool of different data sets and modeling efforts in a way to utilize across the region. We're using the evapotranspiration effort to look at different climate and biological responses within our domain, and Darren has really done a great job of pulling this together using a Shiny app development application, which he'll describe. And I'll turn it over to Darren at this point.
Thanks. So this is just going to be sort of a summary of the work that's been going on for actually right about a year now, just to give you a sense of where we're coming from and how our thoughts were influenced towards this goal now of creating these targeted web applications for people to use to analyze climate data and help with management and decision making. So can I actually move that a little bit or shrink it? Okay. So there'll be kind of three main parts to this just quick overview. The first was some of our initial efforts at comparing several ET models like Dennis had described, which led us into exploring using an R package called Shiny for creating interactive data visualization applications, all within the R programming software. And finally, some of our recent efforts towards scaling up this idea of a web application using Google Earth Engine. So right when I first came and started the postdoc, Dennis and Gabriel were interested in trying to compare two evapotranspiration models. So there's the CSU model Descent that Dennis and Bill Parton had been working on, and then Gabriel's CBOP model. So we have two kind of fundamentally different models here. So it was a challenge just in terms of how do we even begin to compare these two models together. So the specific run of Descent that what I'll be talking about here was just dealing with this region in the kind of north central US. Is approximately about 400 some counties within that particular model of or particular run of Descent. So we're limiting our analysis just to those counties. So initial data processing tasks. So we have two kind of inherently different data structures. Descent was coming out as tabular data. So for each specific county, we had a CSV file or a text file with a number of different outputs from the Descent model, but we were primarily focused on looking at evapotranspiration versus the CBOP model, which was contiguous United States raster models. And these CBOP is generated from MODIS data, so we're looking at 1 kilometer scale spatial resolution to that model results. So there are different spatial and temporal scales as well. Descent was providing results at daily time steps and aggregated to counties, whereas CBOP, with a specific set of CBOP results we were working with, were monthly aggregates, and as I said, those were at 1 scale kilometer pixel resolution. So there were issues of data wrangling just to get these two models and results to even work with each other. So for what I'll be talking about here, the study area was, as you can see right here, it's approximately 450 some counties that we had DayCent results for. DayCent was run just to simulate or estimate evapotranspiration in grassland sites. So we applied a grassland mask, which is seen here in the gray areas, which brought us down to about 300 plus counties that we were looking at after we had masked out that actually had values within the grassland mask. We had 16 years worth of data. This was kind of driven by CBOT being based on MODIS. So we had from 2000 to 2015 for CBOT results, and so we flipped the DayCent results to be a similar time frame. So once we finally did the kind of ugly data wrangling process, we were stuck with an issue. How do we actually look at this? How do we look at these results? So we had 300 plus counties, we have 16 years, we have 12 months per year, and we have 2 different models that we're looking at, which leads to a lot of figures. So we were trying to figure out, do we want to, are we looking at 4-page PDFs per county? And Dennis had been to a presentation where someone had shown the use of these interactive Shiny apps in R. And since we had done all of the data processing in R, we thought we would actually take a look at it. And so we had kind of 3 main goals in terms of how we wanted to proceed with the analysis. We wanted to be able to try and pick up on regional trends throughout the entire area, look at county-specific trends or county-specific information. We wanted to try and have this aspect of interactive data exploration. So for the regional comparison analysis, we were looking at what's the just general correlation between these 2 models. How do they agree? So we're kind of filtering out this idea of time, and we're just looking at just across the board, how much do these 2 models agree? We're also looking at spatial patterns. So is there variation in north to south, east to west gradients between the correlation or how well these 2 models agree? And are there any specific county outliers within these larger trends that we can identify? County level comparisons, we were interested in looking at for a specific county, can we see that full monthly time series for both models of ET estimates? Then can we also break those down into kind of aggregations, looking at anomalies for monthly or growing season or quarterly, annual anomalies? Can we see multiple time series? And then we're also interested in seeing the underlying distribution of CBOT values. So for county at a given month, we're looking at either the mean or median CBOT value. And so some of these counties, as you can see highlighted here, had very few pixels that remained after the grassland masking. So we were interested in seeing, are these distributions of CBOT values really skewed? And that's why our means are kind of off between the 2 models. And so we wanted to be able to see what the underlying CBOT values were as well. And interactivity, we wanted to be able to actually have interactive mapping. So we wanted to be able to see these results and comparisons actually on a map. We wanted to be able to interact with that map. We wanted responsive figure generation. So we wanted to control which counties we're looking at when we identify which ones are of interest with the trends. Can we control which figures and time series we're actually seeing? And how many visualizations do we want to see at a time? What's a good kind of size of number of visualizations that you can process while you're viewing this at a given time? And so we began to look, that data processing step took about 2-3 months. Then we began to look at trying to incorporate this into an interactive Shiny app. Shiny, if anyone's not familiar with the package in the R software, it allows for creating interactive web applications. So you're able to program all in R.
I always thought you guys were talking about Shiny app because it looked cool.
It looks really
good. I didn't realize that Shiny was actually the name of it. I've been hearing this for 6 months.
I think they did that on purpose.
Now I know what you're talking about.
They do look nice. So we spent, I think, a couple of months or so, and we ended up creating and kind of hitting most of our targets for creating this interactive web application. So up here you can see we have this interactive map. This is actually using an applet called Leaflet, so we can embed this interactive. There's actual results or information in here. So this color gradient that you see by counties is actually showing you the degree of correlation between the 2 models, darker colors that indicate the model more highly correlated in those counties. Then we have the ability to actually interact with it. So down here we can, in the map, we can hover over it and see general like correlation statistics, whatever we want to see, but we can actually enter in different county codes, and then we can generate a whole new set of time series. So there's multiple time series at once are generated just by changing that entry. And then down here, you're able to select for a given date. We can actually look at those interactive, or look at those underlying the CBOT distribution values. So it was fairly successful. And then we started to say, well, that's great. Look at the raster values. Here's where we started to see some of the limitations of a Shiny app. So the leaflet app where you're looking at that map is excellent for vector data. It really struggles with raster data. So even loading one small CBOP image kind of ground the app to a halt. You were looking at minutes just to load a single image with no interactivity there at that point. So raster loading and visualization it was a huge challenge, and it was just sort of something that kind of stopped development in trying to incorporate that. Then we were also saying, well, we have ET here from DayCent, from CBOP. We also look at Mod 16, another ET product, or can we look at NDVI and start to include those? And that the way that the Shiny app is functioning right now, it's calling from pre-processing that already happened in R. So to incorporate these new data sets, that meant we were going back, kind of starting over again and trying to incorporate all these other data sets. And these are processes that were taking 3 to 5 days to run just to go through single year data sets. So that was not an inconsequential time commitment. It was kind of nice because for really small apps, you did all your, it's just generating visualizations really nicely, but it was really running into some impediments when we were thinking about scaling this up. And then we'd also thought, well, we only have values through 2015 for DayCent. What if we want to run 2016, 2017? And it kind of became the same thing. It's either really complicated data management, or you just go back and do everything again and get it back, which wasn't really desirable. And that led us to, in looking for different ways to handle that, looking into using the engine as a way to avoid this, the problems that happen with trying to process these large data sets, trying to download these large data sets, collating all these different images. And with Google Earth Engine platform, they're actually taking care of the majority of that for us. If anyone isn't familiar, Google is now a planetary scale platform for Earth data science. So they're actually warehousing, pre-processing, calibrating imagery from as many sources as they can get, and their image catalog keeps growing and growing. So for instance, you can get access to the entire Landsat data catalog through Google Earth Engine. You're also now, with Google Earth Engine, you're actually working in Google Cloud, so you're actually doing your processing on cloud, so you're not doing it limited by the local machine. And they have a similar way to image library. They also have an ever-increasing number of algorithms. So Google Earth Engine, you apply to be a part of it, you get whitelisted, and then you get access to their code environment that they've developed. This is really good for research purposes, but we were interested in trying to make applications for end users. So land managers that don't have coding expertise, don't have access to expensive GIS software. So something like this, which is great for researching if you know how to code in JavaScript, that's kind of a no-go for a lot of people who are trying to use these for management decisions. But there are a number of examples out there right now where people are developing these very, very good web applications that are relying on Earth Engine for processing and for data acquisition, but they're creating these standalone web applications where individuals don't need to know how to code on the back end to get the results that they want. And two really good examples, Climate Engine on the left, which is out of DRI and University of Idaho, and then the Northwest Climate Toolbox, which is also University of Idaho. They're kind of taking the lead in developing this. The Climate Engine is sort of global scale GIS for remote sensing data. It's an extremely versatile tool. But we're really interested in what the Northwest Climate Toolbox group has been doing, where they have not only they have these larger spatial apps, they also have these smaller targeted applications that allow people to go into different data processing techniques that may or may not be spatial in nature. So we're kind of using the Northwest Climate Toolbox the way they formatted this with a main page and then access to smaller targeted web applications as our kind of guiding principle, or how we're hoping to structure this as well. So making the jump from a Shiny app in R, where you're doing everything just in R, to actually doing a full stack web development is not a subtle process. So we're now looking at trying to code full stack. We have front end development about how what's going to be displayed, rendered on user web page. But we're also looking at back end development, which now Google Earth Engine has a Python API, so you can code in Python and get access to Earth Engine algorithm processing and data sets directly from a standalone web application. And we're really pushing now to make Earth Engine a part of what they call Google Cloud Platform. So the apps such as Climate Engine, it's using a really similar structure for front end and back end, and that's actually where we started to figure out, looking at how they built that, what components we needed. But it's using Google Cloud Platform. It's constructing the app in Google App Engine, which then gives you access to a number of other Google tools outside of just Earth Engine. And I'll show you a couple ways that those manifest. So we have a couple different versions of sometimes toy examples, or sometimes just trying to get specific functionality in several different applications. So I'll show you a couple of the things that we've created just in a testing phase to give you an idea of how this is hitting some of those analysis goals that we had. So one of the analysis tasks we had was this interactive mapping. So here is an example of an app we built. This is looking at Palmer Drought Severity Index from University of Idaho. So this is from, I think, 1980 to present, or approximately present. So we have this contiguous US data set, raster data set that's rendering. We're locally uploading county shape files. We have Google Maps API, which is rendering all of the background maps that you see. So we're able to capitalize on that coordination between all of the Google Cloud products. We also were interested in the idea of responsive figure generation. So here's another example. This is still with our Palmer Drought Severity app. You're able to now interact directly with the raster data. So we can click on a given county. We can get full time series for that county. And this wasn't something that had to be pre-processed before, like we had to in R. So this is all happening on the cloud, kind of real time. The current task that we're working on right now is this idea of multiple visualizations simultaneously. So can we do this, but then also go into our Python backend and have it create those, say, anomaly time series or any other kind of dashboard displays or visualizations that we think are useful. So that's where we are currently right now, is working on incorporating a series of visualizations in there. The previous challenge of raster loading and visualization is now very, very nicely handled by Earth Engine. So now this is actually looking at a 15-year plus global ET data set. This is 1 kilometer MODIS mod 16 ET data set. And it's all mosaic, it's all calibrated together. So we're able to go in and do something similar here. This is actually looking at country aggregation. So we can directly interact with these global data sets as well. Incorporation of additional resources. So it's fairly simple. It's really simple on the background to switch between raster data sets that are part of the Earth Engine catalog. You change that ID that you're looking at. And the next step that we're trying to look at is, can we actually have that be an interactive part of the app? So with the drop-down menu, can we say, I want these raster data sets to look at? And so that we're working on having that a user actually be able to choose which data sets or subset of data sets they'd like to visualize and process. automated updates for new model runs, that also has become far more streamlined, where we're able to post simple spreadsheet data that we get from new runs. We don't have to pre-process any of the results beforehand. That just happens live with user interaction as it's going on. So that process has been greatly streamlined. And so looking forward, we're just coming back to how we're thinking about this. It's a similar structure to what you see with the Northwest Climate Toolbox team. You have a specific landing page and users can go to. There's a tools menu where specific tools may be targeted to their region or to their site or to a specific project they may have. And they're able to go directly to that tool to access whatever information is pertinent to them. And then they get directed to whichever specific tools they're hoping to use. So just wrapping up a little bit, pros, this is able to leverage some pretty fantastic capabilities of the Google Cloud Platform. It's extremely flexible in terms of tools that you create. So we're not bound by specific visualization or rendering techniques. It's really has access to the majority of the Google Cloud tools. And it also provides, going with these standalone applications, it provides the opportunity to be a hub or a host for multiple tools for different end users. Cons, initial development, as we're learning, is extremely time intensive. It's a challenge. These are really complicated applications with all the different interactions with Google products, but then also different web platforms. It is quite a complex thing. Integrating all of these features, it's somewhat streamlined because, as you can, like in these time series here, there are some tools that are put in place within Google Apps to be able to do these, but to really customize it as much as you could in R or in Python, it's a little more challenging to try and figure that out. And then not necessarily a con, but just something to consider hosting and deployment processes. So these would be, to continue with something like this, these are hosted on Google Cloud. And so it's a part of App Engine. There are ways where there are grants for academic or nonprofit in terms of providing time or space for storage. But it is something to consider about how these things can actually get into the hands of end users. It's not something that you can just say mail an R script to them and have them be able to run it. So that's a kind of speedy introduction, but lots to look forward to in the future.
And so this is Dennis again. In looking at development of this application, is the idea of how do we take these complex sets of information, boil it down into an application that a non-technical user can have access to them and do some quick analysis. And so we're still exploring that, especially with looking at a variety of regional data sets, the climate data sets that we have, both of historical climate, downscaled future climates. How do we actually encapsulate those into these applications? And we're working with our programmer now, Darren is, to explore how climate summaries and analyses across the domain at particular sites can be done to support a tool development that a resource manager can just pull up on his desktop to use a Shiny app to look at climate features. There are other models that are out there that we can look at that people have generated within the region with looking at vegetation changes, species changes. Those are things that are down the road that if we can actually master this, then we can look at future developments. So Darren's open for questions. Gabriel's here as well. So if you have interest or questions about the ET product, Gabriel's able to address those.
Quick question for you, Darren.
Yeah.
The Northwest, are they using in the cloud or is it from Shiny app? I think I missed that.
I think it's a mix of both. So there is one of the primary ones is integrated with Earth Engine, I'm fairly certain, but the rest of them they just appear to be standalone apps
I see.
that would have been Python or R.
In my understanding too, maybe from the USGS side, there is a USGS Google interaction that's been formalized.
I've heard about it, but I don't know much about it.
So, sorry, Mr. Andy has it.
It was about the corporate relationship between Google and USGS on visualization, data archiving.
You know, I know US just signed up with Amazon for some cloud services, but they also, when I talked to Eros, they are not precluding Google. They say, okay, that's what service you better, because Google provides the Earth Engine, which is a GIS capability. We're okay to explore it.
Okay.
And the payment, I don't have exact numbers, but if the service-based, it's not that much. You know, for a lot of processing, it's not more than like $1,000, $2,000 per year for huge global kind of processing.
Yeah. Wow.
And a lot of users. I mean, so far in all the development with having this thing running every day for a couple months now, it's cost a cent more to do. So, you know, they have said it's really user specific in terms of how cost would be implemented. But a lot of the examples you'll see on talks from Google, unless you get a lot of users hitting a site, it's really reasonable.
Looks like Andy has a question.
Yeah, thanks, guys. Boy, this seems like a huge step forward.
Oh, sorry, just one sec. I forgot we turned down our computer audio. Okay, try again.
Can you hear me now?
Yes, we can hear you. Thanks.
Oh, good. Very impressive. Is the idea maybe that this platform would be used for several of the data layers that the CSC is developing as an interface with different users groups?
That's the hope, Andy, that, you know, starting with the ET data set, that was something that we had available to us across the domain, and looking at, you know, sort of this model from DayCent to the Modus product, that was just a good starting point. It did provide a lot of challenges that we worked through, but I think with some of the other, you know, climate data sets that you might have, thinking about how we incorporate those into the structure would be then sort of a useful next step.
Yeah, I would just second your comment about the potential to really enhance the identity of the Climate Science Center by having this available with multiple data layers, with the hope that users groups would get pretty familiar with it and consult it on a regular basis and become a major interface for the Climate Science Center.
So I was going to ask, what's the relationship between this and the primers work? Is it that they both use Shiny, or no?
I guess the current climate analysis doesn't use the Shiny app. Where Chris, we've asked another programmer to come in and assist to look at the development of the R scripts to develop a Shiny app that would support the climate summaries that we generate at a particular, like at Devil's Tower, for instance, or at another regional park or domain, county level, to be able to do, you know, sort of multiple time series of temperature, precip, ET, or, you know, other derivatives, you know, at that, based on the data that we have. And so we're working on that development. So that's one of the examples of one of the data layers that we do have available to us. How do we use this tool then, based on Darren's experience, to develop, you know, a tool that a manager can use?
And I think that's one of the ideas of having this kind of central hub and then going into these smaller tools. Those could each be individual tools for each, you know, site or region. And I think, you know, since all the work that Bob and Tom have done on those primers, are if there are some of those plots that really lend themselves to this interactive format, then taking some of those and putting those in, I think that's it should be a pretty good step. Chris is working on that.
From my point of view, it looks like we're developing a lot of capability to ingest different data sets and then push them back out. That's the development of a set of products that we could give to lots of people flexibly. So if this comes together, then it's going in that direction.
Yes.
Yeah.
And I think they're just thinking about that. There are a couple of things to keep in mind. So Shiny apps are really good at, you have a couple plots that they lend themselves to interactive visualization. And I'm fairly confident you can actually generate reports from that. So if people did get some results they like and they want to take that and present to someone, they can actually do that. The Earth Engine is great for data sets that are supported or housed by Google.
Right. And are too big to manipulate easily otherwise?
Yeah, otherwise, you're downloading them as single images from somewhere to store them. Where it can be a challenge is trying to put data sets so for example, one of the reasons we were looking at using the Mod 16 ET data set is Earth Engine is not hosting CBOP yet. It's on Climate Engine, so somehow they're doing it, but it's not on Earth Engine just yet. So we went with one that we could get right now, and that would be a situation where for us to try and post all of the CBOP data as an asset, which we can do, then I think we're potentially getting into, we would exceed our quota, and we wouldn't, then you're either paying for more space or it's just not possible. So there are some things to consider about. It's kind of nice to have two options with the Shiny stuff for kind of smaller scale and Earth Engine for larger scale, but it can be something to consider about if you're trying to put a lot up on Earth Engine, which is one of the tests we ran for that first Palmer Drought Severity Index. We were looking at just using a shapefile for county data for locally. So it's just on a local machine and doing that. But if we were to actually try and deploy that, you'd want that somewhere where the servers can actually have access to it on the cloud.
Any other questions for the group here?
It looks like MTS had his hand up. MTS, I'll go ahead and unmute you if you're ready. Just one sec here. Where are you?
Up top. Red.
Okay.
Can you hear me now?
I can hear you, thanks.
Okay, thanks. Thanks for the presentation, Darren. Pretty neat. I just want to mention one thing that there was a lot of audio quality was low today, and maybe it was because somebody didn't mute themselves. But I just want to mention that because we're using a new Zoom platform, so I'm hoping it's not that, and it was just somebody's phone was on. So we had some difficulties hearing most of the time.
Okay. Yeah, thanks. Well, we did record this, so we'll check the recording and see if maybe if that audio worked out better, and hopefully you guys will be able to.
Okay, thanks. So my question was, so I do use the Climate Earth Engine quite a bit, Darren, and you mentioned, a tool for end users, and my thinking there is that that even I'm challenged when I use the Climate Earth Engine at times and to generate plots and figures and just understand what the graph is telling me. So I just want to reiterate what Robin was saying, that these tools really help us, the experts, and to kind of just have a quick access to the data and develop these figures if somebody's requesting us for those kind of information. But I'm not entirely sure if some of these platforms are ready for end users right away, although they could be trained, and many of them could be trained into that, but I would most likely say expert users.
So I totally agree, and that was something that Gabriel and I have talked about, where something like Climate Engine and Earth Engine, those are really good for researchers, but you're right, there's a steep learning curve to those, and that's where something like that Northwest Climate Toolbox that we were showing, where they actually did break out these smaller applications that are just addressing specific issues to, in their case, land managers in the Northwest. That's where we're thinking there's the opportunity to try and present these tools to end users in a way that's not overwhelming.
Right. Okay, thanks. Yeah, I still need to look at the Northwest Climate Toolbox and see, how easy it is. I just was just browsing through that. I see that they have a dashboard there, and so for example, the CSC has been mostly targeting the Western Water dashboard, and we have gotten a separate dashboard that covers our North Central region. And so, yeah, I mean, I'm just wondering if we, as a community, should think about something like what the Northwest has done for North Central, or if that's a model to go, and then, or do we have to go that direction? So yeah, I guess this is something that's fruitful for future discussion.
Yep. Well, not seeing any more, I guess, questions emerging. Thanks for listening in. Stay tuned. I think we're on the. It sounds like we're on the right development path, and Darren's been really resourceful in pulling this disparate information together and really helping us get on the right page with these visualization and analytical tools. I don't know if you have any last words, Darren, on this.
Not really. I mean, I think you know, we kind of keep chipping away at it, and every time we get something else, it's an exciting opportunity. I think to try and capitalize on some of this, and I think the real opportunity is using these as tools for end users, and not necessarily to try and replicate some large-scale research tool. So I think MTI's your comments are really, really important, I think.
If you have students or technical support people working on our applications and things, that it might be something for us to consider having a small working group, just to have a monthly, or just have a blog, a support group within our region of how we develop these things. If we might, sort of working with Jill Lackett and others to kind of maybe circulate that sort of point of interest and see whether there is enough critical mass out there. Because I think more people kind of sharing experience actually moves this development more quickly along.